Welcome, my name is Craig Otto. This is Statistics for SPC, Operational Excellence, Class 2015 for Rhodes State College. Welcome everyone. Here in week 1, we're going to just go through some basics for statistics. Basically, when you have data, there's different ways you can describe the data. First, you have what are called measures of central tendency, which kind of tells where does the data center around. And then the second is your measures of dispersion, which talk about how is it spread about that center of the data. So I'll go ahead and get started here with measures of central tendency. You've actually probably heard of most of these, but the first one is average. And what the average is just summing up the total of the data and dividing it by the total numbers in the data set. So like for example, we have a data set here of 8 different numbers, and when you average those, it comes out to 5.25. And the way that I did that is you add them all up and then divide it by 8. And actually Excel does it for you much quicker. If you want to look here, you can average the data here. You just come in, type in average, highlight your cells, and hit enter. 5.25. The same thing can be done for something called median. The median is actually when you sort the numbers from smallest to largest and then select the middle number. And if it's, for example here, the middle, I put my numbers in from largest to smallest. The middle falls between 5 and 6. So you can see it was sorted. And then the middle, there's 4 on this side and 4 on this side. So there's no middle number for the median. So it actually becomes the average of these two. So the average is 5.5. And that's what you see here. Now in Excel, you can do this very quickly. You just equals median and do the same thing. You can come in and actually select your data and hit enter, and there it gives you 5.5. The mode is pretty simple. It's just the value that happens the most frequently. So when you basically do a tally of it, you have 5 and 7. And in Excel, you can actually do this calculation as well. It's just equals mode, hide your data, highlight your data, and then hit enter. So it's 5, and then 7 is also. What it does in Excel is it just takes the first mode that it finds. So actually, it's kind of safer to just put your numbers in order and then count them up, which ones happen the most. So when you start looking at things in terms of a histogram, you can start seeing, here's one histogram, and you can see the mode, the median, and the mean will all kind of fall towards the center of that. But sometimes you have data that doesn't follow like a bell-shaped curve. It might be sort of skewed to the right, where the mode is always the highest point, and the median is always the middle of the data, and then the mean, on this particular one just happens to be down here. So you got to be careful when you talk about these measures of central tendency. On a normal curve, the average, the median, and the mode are all the same number. That's if it's perfectly normal. Now when it's not normal, something like this curve here, that's when you're going to get different values for them. Now everything I've just done in Excel can actually easily be done on the TI-83 Plus. I think it's important to know both. You have to know how to use Excel. In the workplace, I use Excel all the time for data crunching. When you take tests, for example, if you want to take the American Society for Quality ASQ CQE or a different exam where you're going to have statistics, I highly recommend you get to know the TI-83 Plus very well, because you can't use Excel on that exam. You got to bring a calculator. So when using your calculator, you just enter your data into list 1 and select stat, calculate one variable statistics for that L1, and it'll spit the numbers out for you. If there's any questions on this, you can also use YouTube. There's several videos out there. Just type in average or median or statistics on YouTube, and you can find all kinds of examples and ways to learn more about statistics, more than what I'm showing. Second way to describe data. So we talked about this, the center of tendency, of how that works. But then you also need to describe the how is it spread about the mean or the median. So in that way, in that sense, we have also three measures of dispersion. The first one being range. That one's the simplest to understand. You just take your data set, find the maximum value in your data set, find the minimum, and it becomes 8 and 1. 8 minus 1 is 7, so your range is 7. For the standard deviation, this becomes much more complex, but basically you have Excel to help you out. I actually did it myself the long way here just to show how to do it. If you just take the number and you find the average of the numbers. So the average was 5.25, and then you take that and subtract your x, which your x is just the data point. So you can see this data set is the same as this one right here. So you just take that data, subtract your average, which is called x bar. Don't make it any more complicated than it is. So when you do that, you take those and you subtract them. That's what you see here. And then you square it. Square it means take it times itself. So minus 4.25 times minus 4.25. And that's what you get here. You add all these numbers up, sum those up, and it's 37.5. You have a total number of samples, which is n. So n divided by 8, and then so there's that number, 37.5 divided by 8 is 4.68, and then you square root that. Now that's a pretty complicated way of finding standard deviation. And the nice thing about it is, in the calculator, it calculates that for you. You just use this process. In Excel, you got pretty simple. Standard dev is the formula. So you just take the standard deviation of that, and it comes out 2.314. You might say, why didn't it come up to 2.16? Well, there's something called population and sample standard deviation. So you got to pay attention to which one you're using. Population means you're looking at the entire data set, whereas sample means you're only pulling some of it. You don't have the entire population of the data. So you got to know which one you're talking about. If it's all of them, then you're talking about population. And in that case, it's just using the formula standard dev. You can also use it if you want to do sample. You can do that as well, and I'll show that here. So it's equals standard, and you can see how Excel just fills it in. And I'm going to scroll down here, and you can see right here, standard dev A says estimate standard deviation based on a sample. So that's the one I want. I hit tab, and then I just select my data and hit enter. So there's your 2.31455. And let's say I want population, standard deviation, population. So here you can see standard DP does it for the entire population. So you just highlight that, and voila, 2.165. So there's these numbers right here, right here. So depending on which one you want, whether it's the whole population or sample, you just have to select the right one. Okay, so just to recap everything we went through with standard deviation. If you want to find the population standard deviation, that's where you use the standard dev P. So what you're typing in is actually equals standard dev P, and then you start your parenthesis, and then you put in your cells. You'll highlight your cells and end the parenthesis. And then on this end, what you're actually typing in is standard dev and then A. And the reason I am typing it in with the little apostrophe is so you can actually see what you need to type. When you actually type it, you just need to put equals, and it'll capitalize the letters automatically. You don't need to worry about capitalization. So that's what it is for sample, and this is what it is for population. Okay. Now variance is actually more used in calculations and less for describing a population. So I'll go ahead and describe variance. Variance is just the standard deviation squared. It's pretty simple. You'll see this little sigma sign. I didn't mention that, but that means population standard deviation. And then if you just see a regular S, that's sample. So you have the same thing with variance. You have a population variance, which is just your sigma or your standard deviation squared, meaning you just take it times itself. And the same thing for sample variance. Sample variance is just the sample standard deviation times itself, so it's squared. So pretty straightforward. I mean, it doesn't need to be harder than it is. You won't use variance a lot, at least initially, and it's hard to visualize what variance is. You'll deal more with standard deviation. So just a quick visual to describe some of what I'm talking about. Here you can see a population. This is what we call a bell curve. But as the standard deviation, I want to show you as it increases. So right now it's a standard deviation of 1. As it increases, notice how, let me go in this one. Notice how it becomes more spread about the mean, more spread out. And the larger the standard deviation, you can see it becomes more spread throughout the whole process, versus in the blue background, which is the standard deviation of 1, it's more centered about the mean. You see the mean in both of them is 10, but the way that the data spread about it is very different. And the larger the standard deviation, the more spread it is. So you can see it kind of flattens out. So that kind of shows you what standard deviation is. As it gets less, the tighter the curve becomes, and the higher it becomes. So that's kind of how it works. Whereas the central tendencies, that just tells you where it's at. So you can see like a mean of 14. Even though the standard deviations are the same, the mean, the center of the distribution is different from each other. So that's kind of a good visual of how central tendency and measures of dispersion are different. You can see as standard deviation increases, so do the curves, the size of the curves, and how it's spread about the mean. So that's an example. Again, you see these curves. Well, sometimes you want to make what's called a histogram. And the way that you create a histogram, you have a data set over here of quite a few data points. But let's say you wanted to create a histogram, something that looks like this. This is just a quick process on doing that. Number one, you compute the largest data value minus the smallest. So that's 13 and minus 1. So that's 12 divided by 7. And that's what I did here. I took the max minus the min and divided it by 7. And that gave me what's called the class width. And that's the second operation you need to do with that class width, is increase that value to a whole number. And what I mean by that is just round it up to the nearest whole number. So 1.7 rounds to 2. And then what you can do is you kind of create limits. So the minimum was 1, so that's what you start with. And you wanted 7 classes. Classes is just the different groups that they're in. So you can see here's 1, 2, 3, 4, 5, 6, 7 bars for 7 classes. And what you do is you just kind of create limits. So for each of these, your class width's 2, so 1 to 2, 3 to 4, 5 to 6, and on down all the way to 14, which your max was 13. And then you just count up the number of times it's between 1 and 2, number of times it's between 3 and 4, between 5 and 6, and you just tally them like a tally sheet. And then that's what you start mapping then on this process here is where does that data fall. So you can see the frequency of 2 falls between 1 and 2, or a midpoint of 1.5. Midpoint is just basically the middle of these two numbers of your limits. So this is just a quick way to kind of see what a histogram would look like and how it would be made. You can also make this on your calculator. Just simply enter it into L1 of your data, or list 1. Select the histogram plot, and then set your windows. There's a value that you can set your X-min to, which is basically your lowest class boundary of 1, and your X scale value, which is your class width, which in this case is 2. And then you hit graph, and then it'll spit something that looks similar to this. So that's this week's lesson. I'll try to post some more basically summaries of your formulas that you use in this lesson, and I'll also try to have a discussion board if there's any particular questions on it. But other than that, go ahead and do the worksheet for this week, for week 1. It's going to be revolved around using your central tendency formulas and also your standard deviation and your measures of dispersion formulas. And there's also a few questions about histograms and the curves. So basically just be prepared for that, and feel free to shoot me questions on the discussion board. Thank you.